Okay, let's go and get started with what we're going to cover today. First thing is, and I know this is probably pointless to say, but I noticed that the number of people actually watching these lectures is very low. There's like 20 people in the class, and I get like 2 or 3 people watching the lectures. And that's a little bit disappointing and problematic, but those of you who are watching this, thank you for doing that, and really, you should thank yourselves for doing that, because the stuff we're learning in here is really kind of useful and powerful stuff, and you're going to need it in the next class. You're going to need it on the final exam for this class. You're going to need this stuff for your career, and it should be fun. Like we're programming games in here. This should be fun stuff. Watching a half hour or 40-minute lecture that tells you how to do really cool, powerful things should not be something that is overly burdensome. Especially since you guys have signed up to be in this class and supposedly want to do this kind of stuff with your lives. And the more you learn about programming, the more fun it becomes. The more it's like being, again, I've said this before, it's like being a wizard. So the more spells you learn, if your only spell is to, I don't know, like make a candle get blown out, not that much fun. Not many places you can do that. But if you can suddenly enchant things and make things appear and make things disappear, and you can fly and you can make stuff come to life, and you can do whatever you can imagine, suddenly it's really cool and really fun to be able to do that. But you have to learn the basic stuff. You have to learn the foundations. You have to know when to use them, and you have to practice it. And so if you're not watching these videos, then I guess there's 2 possibilities. You either already know all this stuff and there's no reason to watch it, which I know is not true based on the performance on the midterm, or you're just in the habit of getting on the internet and playing around on Reddit and looking at memes and wasting time doing other stuff and chatting with people on Discord rather than watching the video and doing the work. So I would encourage you to watch these. And I would encourage you to take the class seriously, because if you do not have the stuff you need from this class, the final exam is going to be difficult, and you're going to miss out on some really cool stuff. You're going to be, at some point, you're going to wish that you had paid attention more. Okay, so anyway, let's, now that I said that to the people who are on here watching it, let's go ahead and get started with what we're going to get through today. And then between today's class and next class, some really cool stuff is going to happen. We're going to suddenly have dozens of things happening on the screen all at the same time, and it's going to be really easy to do that. So our starting point for that today is this topic called sequences. And we've actually seen sequences before, we just didn't know it, but let's go ahead and dig in. All right, first off, a sequence is essentially a way to store multiple data items together under one variable or one name. So think of it like a list of things. So you have, I don't know, like here's a paper that has a list on it of stuff. Here's a list of things, all stored together on one sheet of paper. So that's the concept of what we're doing here. And we've actually seen some sequences before. We saw strings. So for example, the string is being a sequence of characters like hello. Well, what's this list of multiple data items? Well, there's an H and an E and an L and an L and an O, all stored together in that one string. So multiple characters grouped together as one item. We've also seen sequences with colors, and this is actually called a tuple. But you'll notice we have a red component, a green component, and a blue component all grouped together in those parentheses as one unit. And we've also seen lists of points when we made polygons, like we used that polygon feature on our previous example code that we did with the rotating ship and the thrusters. But if you notice, the way we put those in is we listed out the points. Here's the first point, here's the second point, there's the third point, they're in these square brackets. That's a list of points that we put in. Now, these are all different types of sequences: strings, tuples, and lists. And so let's take a quick look at those. So a string is a sequence of characters. Here are a couple examples of the different strings. A tuple is an immutable sequence of data items. We'll talk about immutable versus mutable in a second. But things like a color, and maybe we were making some sort of a fantasy game. We wanted to keep track of the different races: human, elf, orc, halfling, gnome. whatever. It could be other things in that list as well. But you'll notice that we can put those in here and store all of these things, 1, 2, 3, 4, 5 together under that. We've also seen those tuples returned when we got the mouse position or the mouse button status. And we also had a giant tuple that's returned when we looked at the keyboard input. When we said keys equal pygame.key.getPressed, that returns this giant tuple of a bunch of zeros and ones representing what key, one wherever a key is, in whichever position is for a key being pressed. But anyway, we also have lists, which is a mutable sequence of any kind of data item we want. So it could be, in this case, a list of strings, or it could be a list of numbers. And we're going to look at that. But you'll notice the difference between these. Strings are in quotes, either double or single or triple. It's just something in quotes. It's a sequence of characters. Tuples are a group of data items listed and are separated with commas inside of parentheses, like this for color, or this for this different races, these different strings. And then a list uses square brackets to enclose it. So we can tell them apart by if something's in quotes, it's a string. If something is a sequence of things in parentheses, it's a tuple. If something's a sequence of things in a square bracket, it's a list. And we're going to talk more about lists here in a little bit. And we're talking more about mutable versus immutable. Now, before we do that, though, sequence operators. Sequences have special operators that work upon them because it's not like a single data item like x equal 10 where it's just holding a number. It has multiple items in there. And because there are multiple items in there, there are some certain things that we need to think about or be able to do with those lists. So the following operators that we're going to go through, they work on all of these sequence types that we saw back here: strings, tuples, and lists. All right, so the first one is the in operator. And the way the in operator, or what it does, is it basically tells us true or false if something is in a list. So in other words, think about it like you have a doorman at an exclusive club, and he has a list of names of people who are allowed in. And somebody comes up and he's like, "What's your name?" They tell him, and he's like, "Okay, I need to see if that name is in my list somewhere." And if that is in that list somewhere, then they'll return true. If it's not, they'll return false. So this will work on any sequence type where we basically, the syntax is whatever thing we're looking for, the operator in, and then the sequence that we want to look for it in. And that sequence could be in a variable. This value that we're looking for in that sequence could be in a variable. Or we could put it in explicitly like I did down here. So for example, this first example here is quotation mark, or is exclamation mark, is this string somewhere inside of this string? And the answer is yes, because there's an exclamation mark at the end. So this will produce a true. Or I could look for something longer, like test. Is test in this string somewhere? Yes, it is. There it is right there. Produces true. But we could also use this for tuples and lists. For example, is the number 255 in this list of colors, this tuple of colors? In this case, it would be false because none of them is a value of 255. And here's one where I'm looking for a string in a list of other strings. Is the string Ohio in the list Kentucky, West Virginia, Pennsylvania? In this case, it'll be false because it's not in there. If it was in there, it would return true. So that's the in operator. And then there's kind of the opposite of the in operator, which is the not in operator, which works the same. You say X not in S, and it just returns the opposite. If the thing is not in the list, it returns a true, or the sequence, it returns true. If it is in the sequence, it returns false. And here are those same examples, but with not in rather than in. You'll notice it just inverted these. They were true over here and false down here, but in the next one, false up here, true down. So it's really just the opposite kind of thing. Hey, is this not on my list? Or is this in my list? Okay, now another one is the plus, which is also when we're dealing with sequences, it's referred to as the concatenation operator. And what concatenation is, it's taking one sequence and another sequence, and it's putting them together and making a new sequence out of those two by sticking one after the other. So in this case, S is going to be first, T is going to be stuck on the end of it. So here are some examples. Hi plus there produces the string hi there, all run together. Notice no spaces added between them. It'll just take this sequence, join them together to make a bigger one. And here that is happening on a list. Here's a list 10, 20, 30 plus the list 40, 50. Those two lists, when we combine them, they make this bigger list 10, 20, 30, 40, 50. So that's the concatenation operator. And another one we've seen before on strings is the repetition operator. And the way the repetition operator works, it's like the asterisk or the multiplication thing we've seen before. But if I do that with a sequence and a number, then that's going to basically say concatenate this string, this sequence with itself this number of times. So this is what we talked about before as like string repetition. It also works on any sequence. So down here, for example, high times 5 produces this new sequence, this new string, high, 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 5 total times. Or 1, 2, that list times 6 is going to produce that repeated 6 times. So there's 1, 2, 3, 4, 5, 6, so 12 total items because we concatenated that with itself to get a total of 6 times. Okay, so moving on from there, the length function. The length function tells us how many things are in a particular sequence. So if I use that on a string, it'll tell me how many characters. If I use it on a list, it'll tell me how many individual items there are in that list. If I use it on a tuple, it'll be how many items are in that list. So notice that with howdy, that's saying that's a string, so it's how many characters. 1, 2, 3, 4, 5, 6. So that will produce a 6. If I do the length of 1, 2 times 6, well, that's going to expand that to 12 total items. So that's going to produce a 12. And if I use it on this color, like 255, 0255, it's going to produce 3. So notice that this works on strings, it works on lists, it works on tuples. The length will work on any of these. Actually, all of these so far will work on any of those sequence types. Now, we can also select an item at a particular index position of a sequence. So when we do that by using these square brackets after the name of a sequence. So for example, if I have a sequence and I put the square bracket with a 0 inside, that's going to give me the first thing in that sequence. If I put a 1 there, it'll be the second thing. So note that the index values start at 0. So the first item in a sequence is at index 0. The second one is at index 1, and so forth, all the way up till we get to the end. Also, that if we use negative index values to pick something out of a sequence, that basically says start at the end and work our way backwards. So -1 is going to be the thing that's at the end of the sequence. -2 is going to be the second to last thing in the sequence. All right, so here's some examples down here. As S, this string equal hello in quotes. So S sub 0 is that H. S sub 1 is the E. S sub 2 would be that L. Sub 3 would be that L. Sub 4 would be the O. And then there is no 5. But if I did -1, that means start at the end and go -1. The one right before the end would be that O. So note that and this works not just on strings, but any sequence type that we would want to look at. We could use that for a list and get the first thing in the list, use negative with a 0 index, use -1 to get the last thing. If we want the second to last thing, we could use -2. If we want the second thing from the front, we could use 1. So basically the index is just count us into that sequence. Now we can also do something with a range of items rather than selecting just one. So this is kind of like giving a subsequence of a sequence. And the way that works is you basically, there are a couple ways that we're going to show that works, and we're going to look at some examples on the next page. But notice that you put a starting index, and then the colon character, and then the ending index. And so when I do that, that says start with the index I. Again, the indexes start with 0. Or start with index number I and go up to, but not including this index number J. That's important to note. It's not including the second number. It's up to it, but not including that. Now, here are some usages. There's just I colon J, but if we leave the thing before the colon out, we just have one number after the colon, that means it'll assume starting with 0. If we leave the second one out, it'll go from this index number up through the end. So we can leave any of either the one before the colon or the one after the colon out, and it will start at the beginning or go up through the end. Now there's a third thing we can add on the end, another colon and another number we can put there. And that says start with I, go up to but not including j, and then step by k. So if the default step is 1 if we don't provide k, but if I put it 2, it would go every other one. It would start with I, and the next one would be I plus 2, and then I plus 4, and I plus 6, and so forth. We could put whatever step we want. We step by 2 or 3 or 4 or 10, whatever we want. All right, let's look at some examples here. Okay, so here are some examples. So my string S in this case is game over, loser. So 0 through 4. So let's look at what 0 through 4 would give us. That would be 0 is the G, so it's going to have that one. And then plus 1, 2, 3, and up to, but not including 4, which is the space. So we're just going to get G, A, M, E, and that's it. Not including the space, and there is no space on the end. Now, if I say 10 on, well, let's count that one. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is that L. And then since I just have a colon that says start with the L, go all the way up through the end. So that's going to give us just loser. And if I say slice 5 through 9, well, 0, 1, 2, 3, 4, 5 is that capital O. And then up through, but not including 9. So that was 5 where we were, 6, 7, 8, and 9 is the space. But what's not including a space, we just get the word over. And now here's a case where I'm using the step. So down here, I'm saying start at the beginning, go all the way up through the end, and then step by 2. So we're going to get the G and then count 2, 1, 2. The M, count 2, 1, 2. The space, and then 2, 1, 2. The V, 1, 2. R, 1, 2, L, 1, 2, S, 1, 2, R, 1, 2, and then we're off the end of that, so we're done. So, oops. One of the things that's important to note about that is slices can work on tuples and lists, not just strings like we're using here. So keep in mind that all of the things that we're seeing so far will work on strings, we'll work on tuples, and we'll work on lists. Okay, a couple more functions here. The max function will find the largest item in a sequence. So if we're using it on a string, it'll give us the largest ASCII character value, which in this case is going to be Z, cap or lowercase z. But if I use it on a list of numbers, it'll give me the largest numerical number, in this case 50. If I use it on a tuple, it'll give me the largest one, 255. Now, just like there's a max function, there's also a min function, which gives us the smallest one. And so if we do that same things on these same 3 things, but we do the min one, we're going to get the F, since that's the lowest alphabetic one of those. In this case, we're going to get the 10, since that's the smallest number. And we're going to get the 0, since that's the smallest number in that tuple of 0, 255, 200. Okay, now a little bit more with lists. So we've looked at lists, but remember a list is a sequence that can contain any other data item. So that could be strings, it could be numbers, and as we're going to see later, it can also be other sequences and other lists. So for example, this is a professor's variable is a list of names of strings. This numbers array where I have these Fibonacci kind of sequence going on in here, that is a list of integers, just numbers. And then down here, this team colors is a list of colors. I've got like red and then blue and then this kind of magenta color. So that could be used for defining team colors for some online game or the outfit of your player. So notice we save that, or it could be different teams. There's the red team, there's the blue team, there's the magenta team. But anyway, notice that this is a list of tuples, which are themselves lists or groups of 3 integers. And we can also do that here. Here's a list of 2 triangles. So here's a list that has 2 lists inside it. This list has 3 points. This list has its own 3 points. And so now we have a list of 2 things that each have 3 things inside of their list. And each of those things in their list has 2 things. And so this can actually be pretty useful. These lists, are, as we're going to see later on, are going to be a really powerful thing for us to understand how to use. Now, back to this question, we talked about immutable versus mutable. Tuples are immutable, strings are immutable. And that basically means that once you create that tuple or string, you can't like go into it and change just parts of it. We could replace the whole thing with a different string or a different tuple, but we can't go in and say, okay, here's hello world, let's just go in and change just the W to a different character. We would have to get rid of that whole string and put a new one in. And lists, however, are what are called mutable, which means they can be changed, they can be modified. So mutable essentially means, just like the kind of base word mutation, or a mutant is something that has changed. A mutant is changed from the original form. A mutation is the gene has been changed. So if something is mutable, that means it can be changed, in our case, in some way after it was created. And so what that means for us is with a list, you could make a list and then add things to it to change it, to grow it. You could take things out. You could put things in a different order. You could go in and replace one item. And so think about tuples as being like something that's kind of set in stone or carved in stone. And the only way to get a new version of that is to break up that stone and make a new one and carve the whole thing. Whereas with a list, it's rather than thinking about something set in stone, it's more like something written on a whiteboard. And you're allowing people to erase parts and rewrite them or add something new, or think about it as like the ability to change that thing. Now, because they're changeable, that means we have some other operations on lists that don't work on strings or tuples. Let's look at those. All right, so here I just put on this one page this whole list of these, and we're going to end up using quite a few of these. So the first one is we can actually select an item and then replace it with a list. So I could say, hey, go into this sequence and go to item number 5 in that sequence and change it to some other value. Totally fine, because lists are mutable. We can go in and say, hey, the item at index 0, let's change it to some other value. I don't like what it is, or it needs to be something else. We can also replace items in some range to some other value. So I could say, hey, take item I don't know, like 1 through 3, and put this other item in place of those. We can also take an item out by using del and then saying the index number of the sequence that we want removed, or the sequence we want to remove that value from. And then that next line there, notice you can actually delete a range of items. So you can say, hey, don't delete just one, delete any of them from I up to but not including j. And now append is useful. That allows us to add something to the end of a list. Remove allows us to remove an item by its value. So I could say I have a list 1, 2, 3, 4, 5. I want to get rid of the 4 out of that list. Remove 4. Insert lets me stick something in. Append always sticks it at the end. Insert would allow me to put it at the beginning or somewhere in the middle of the list, wherever I feel like it. And the way that works is I say, here's the index where I want it inserted. Here's the value I want to be stuck in there. So that insert will take that list, move all of them over, make space for a new one, and add it in before that point at that index. Now, s.count counts how many times some value appears in a sequence. S.sort basically puts it in sorted order. There's some options for that, whether you want ascending or descending or how you want to sort. But it does, by default, put those things into an order that can make grading sometimes difficult. So the main thing to note there is that with sort, make sure you know what order you want. If you want ascending, you can put it in ascending, and there are options for that. And I'll show you that here in a second when we look at the docs for that. I'll pause this and we'll go look at that. But just make sure that if you have an assignment and it says put these into sorted order in descending order, make sure you know how to do that. Same thing with ascending order. And make sure when I do that, that the default behavior of sort is to put it in ascending order. And what that means for strings is kind of alphabetically ascending. What that means for numbers, numerically ascending. Descending, obviously, the reverse of that. Now, you can also, if you want, you can reverse the order of a list. So if we have some list and we want to flip it around backwards, so make the first thing the last thing and the last thing first and so forth. So in other words, you're just taking it, and rather than having it go, what was first will become last, what was last will become first. So it kind of wraps it back around so it goes backwards. but you can do that as well. So you could sort a list in ascending order and then reverse it, and now you'd have descending order, which is essentially what happens if you specify the option on how to do something sorted in reverse. But we'll play more with these later. Now, the thing that I want to get into right now, though, is there's this other special kind of loop, and this special kind of loop that we're going to look at here is designed specifically to go through items in a sequence. And it's called a for loop. And the way a for loop works, the syntax for it is the keyword for, and then I, this is some variable, and then this is the sequence we want to go through. And what it's going to do, we have a colon and then an indented section of code. And essentially what it does is like other loops, it's going to repeat that indented code over and over again. But rather than like a while loop where it's looking at some condition saying, is this true or is it false? Is it true or is it false? It's basically saying, hey, this is a sequence, has some number of items in it, go through each item one at a time, and every time through the loop assign this variable to the first one the first time, assign that variable to the second one the second time, and so forth. And that's going to allow us to say, do something like, for example, I could do something like that with here. I could say, go through this list, and one item at a time, read what it says, and then take some action based on that. And this for loop concept is actually pretty powerful. That variable I gets assigned to it and reassigned for each one of the items in the sequence one at a time. And the indented code is executed for every one of those items in the sequence. And what we're going to eventually use this for is we're going to say, hey, for every bullet in my list of bullets, let's move it. Let's draw it on the screen. Or maybe you would say something like, for every inventory item I have, go through and calculate its value or something like that. Or for every enemy, move the enemy, let them make an AI decision. Or it might be something as simple as for every number in this list, add that to my sum, and then at the end I can compute an average. And so this for loop is going to be really powerful. We're going to end up using that quite a bit in our future games. Now, here are a couple examples of using a for loop to go through something. For ch in hello. So that's going to say for every character, so this ch variable here is going to get assigned every time to each of those characters. So for ch in hello. So for the first time through the loop, it's going to be an h. So we're going to say character h, ASCII value, and it's going to print out the ASCII value associated with the h. And there's that ORD, which basically turns a character into its ASCII value. And then the next time through this loop, ch is going to be e. And we're going to have character e, ASCII value for e. And then we hit the bottom of the loop, go back up, and then ch moves on and gets assigned that. So in other words, the first time through the loop, ch is capital H. The second time through the loop, it's e, lowercase e. Second time, lowercase l. Third time, or fourth time, lowercase l. Last time, lowercase o. And now we're at the end of the string, so then the loop stops. Here's another example of going through a list of numbers instead of a sequence like a character. So my list has 1, 2, 3, 4, 5 things in it. So I'm going to say, hey, for every value in my number list, add the value to the sum variable, and then at the end, print out what the sum is and print out what the average is. And notice I used the length function down here to compute the length of that. So take the sum, divide it by the number of items in the list, and that's going to give us our result, which in our case is going to end up being 30. So those for loops are going to be pretty useful for us. And one of the things I want to mention briefly, we're going to come in right under a half hour for this lecture. So I am going to do another lecture and get that posted to get us started with object and object-oriented programming. But with the power of lists, as we're going to see later, we're going to be able to use, since the list can be a sequence of anything, list of colors, it could be a list of strings, it could be a list of points, it could be a list of, as we'll see later, a list of bullet objects, a list of enemy objects, a list of asteroid objects that are falling to the earth, a list of inventory items, a list of quests or achievements. Pretty much all those things we can actually store in lists, and then we can use that for loop to go through those lists and do something with that. So what we're going to see is those lists used here once we get into objects. But before we get into objects, we need to have a little lecture on those. So what we're going to do next is look for that next lecture, which is on objects. And what objects is, it's going to allow us to do is create things like, You may have noticed that when we're using Pygame, we have the concept of like a surface, and that surface has capabilities and things it can do. Like you can fill it, like surface.fill. You can also do things with that surface, like draw on it. So you say, hey, pygame.draw.circle on this surface. So that surface that we've been seeing in Pygame is actually an object. And we're going to actually look at how do we create our own objects. And the kinds of things that we're going to want to create our own objects in are going to be things like bullets or something like that. Now, before I switch to this, though, I want to do a quick code with using some quick code using lists here. So while we're at like a half hour now, we've gotten through the lecture part, but some of you learn better by watching me code stuff. So I'm going to temporarily switch over to that, and I'm going to make an example here that has like a kind of a star field on the screen, and we're going to draw all those star points. So let's go ahead and switch over to that. So let me switch to, let me get a Python interpreter up and running here, and then I'll switch to that and I'll live code some of that stuff for you here. Hold on one second. All right, now I've got a new file. Let me resize that so you'll be able to see it. And let me switch so you can actually see what I'm doing. And let me move this where you can see it. That's pretty good there. Okay, so here we are. And what I'm going to do is I'm going to put a comment up here. We're going to say make star field with lists. So first thing, we're going to need Pygame. Let's do import. Let's go ahead and bring in math. I'm not sure if I'm going to use it. We're probably going to need random. And let's just get the main skeleton of our program set up first. So to set that up, I'm going to do pygame.init. Just like we have before, I'm going to need a display surface. So display surface equal pygame.display.set mode. And let's just make it 800 by 600, like we've been doing. And now let's make my game loop. So while true, let's enter the game loop. Let's get the pump the event queue. So pygame.event.pump. And let's get the keys state, keys equal pygame.key.get pressed. And the main thing so far that we're going to want to do is I want to have it so that I can exit this game loop when I press escape. So let's say if keys pygame dot k underscore escape. If that's true, then we're going to break out of the loop, and then somewhere in our loop at the bottom we're going to need to do an update display. So pygame dot display dot update, and then after that we're going to want to close the screen. So pygame dot display.quit. Okay, so right now we don't really have our star field yet, but let's just run this and make sure it works. And let me save it in the directory for this class. stars1.py. All right, and let's run it. Okay, so here it is running right now. Notice empty screen, nothing exciting. We hit escape, it closes. We didn't get any errors, so we know we're on the right track with that. Now let's go back to our code. So back to our code, we want to make a star field. So in order to do that, I'm going to need to draw stars. And a star, we could think of it as, well, let's come down here and say like, well, let's draw a star. So let's do let's draw it as just a dot. So here we might say like pygame dot draw dot. Let's do it as a circle. And we're going to draw our circle onto the display surface. And the color, we'll just make it white. And if you remember how the circle expects its parameters to be, it needs a center. So I'm just going to put one at like 300. So right in the center of like filled in. All right, let's run that and see what we get. Okay, so there's our dot right in the middle of the screen. Move that over a little bit. So there's our dot right in the middle of the screen. Now we want to make a whole bunch of those dots to make a star field. And maybe we don't want that dot to be exactly in the center. Maybe we want it to be somewhere else. But if I wanted to make more of these, one way I could do it is just I'd copy and paste a bunch of these and then pick different locations here. Like make this one 300, 300, make this one 450, 320, run that. But notice, and when I run that, I'll get that star field again. So now there's like 3 of those. Looks almost like the Big Dipper going on here. But let's say we want that star field to be random. Well, how would we make it so that this is random? Well, you might think, well, what if I want a whole bunch of stars here? Well, I would have to cut and paste that line a whole bunch of times. So what I'm going to do is I'm going to do this a little bit differently. I'm going to make a star list. So here I'm going to say star list. And that star list, the way I'm going to do that is I'm going to need, since each star has an X and a Y, the first way I'm going to do this, I'm going to say star list X. I'm going to start out as an empty list. Star list Y. I'm going to start that out as an empty list. And now what I'm going to do is I'm going to make a loop that goes through and adds like 100 X values and 100 Y values to each of these two lists. So here I might say like for I in. And this is actually a function called range, which will go through a certain number of times for us. So this is kind of creating a sequence of 100 things for us. And I is going to count through 0, 1, 2, 3, all the way up to 99 for us. So and then inside of here, what I want to do is I want to add a value to the star list X. So to add something to a list, star list X dot append. What do I want to append? Random dot randint. And what I want to add to this list for this random.randint thing is going to be essentially a random number in the range of 0 to 799. And then I'm going to add one to the star Y list as well. So star list Y.append, except this is going to now be 599. So now I have a value in my star list X and star list Y. So now down here, what I can do in my code, I've filled in 100 values in each of those lists. So now rather than drawing this circle, I can just put this inside of a for loop. I can say for I in range. I can put 100 here again. And now notice when I go to draw this circle, I'm not going to put it at 400, 300. I'm going to put it at star list X. But now I'm going to select out the ith item from that. And since I is changing from 0 up to 99 here, that'll get me all 100 of them that I put in there. Now let's do the same thing here for Y. And just for fun to make these twinkle a little bit, let's make this not always draw it at 2. Let's do random.randint. Let's go 1, 3. And now they'll twinkle a little bit. Let's run that and see what we get. Okay, now we messed up somewhere. This needs to be Y. There we go. All right, so here we go. And there's my stars. Now, why aren't they twinkling? We built that in. And the reason they're not twinkling is because we're not clearing the screen each time. So what we need to do in our code here is before we draw all these, let's clear the screen. So let's do a display surface.fill with 0, 0, 0. So we clear everything to black. And now let's see what we get. Okay, so there's my like twinkling stars in my star field. And you might notice that we have, if we were to count those up, we would have 500 of those. So imagine this being drawn behind our spaceship example. That would add a lot to our game. We have this like nice star field, And if I run this, I'll get a different star field each time because those are being selected randomly. Notice how little code it took to make this star field of 100 different twinkling stars. And if I wanted to, I want to add more. Let's double the number of stars and say, what do 200 stars look like? Now, it didn't double. Why not? We made 200, but there's a problem with how we wrote this, and that's that we hard-coded this number here, and it's different than the one down there. So if I change it there, I'm going to need to change it there. So one of the things that I would suggest doing, though, is not necessarily hard-coding. So we could put that in a variable and then use the variable two places, or there's another way we could get 100 out of this, and that is to actually look at the length of how many we put in up there. So in this case, let's look at the length of star list X. So however big that list is, that's how many times we'll go through it. And so now if I put 100 there, I get 100. And if I put a 200 up here, now I'll get 200 with only changing it in one place. If I put like 1,000 up here, now I've got a star field of 1,000 of those. All right, and I would suggest as you write your code, if you're hard coding stuff like that, kind of get in the habit of not doing that. It's better programming to not hard code things like that. Now, there's one other version of this that I want to write that I think is going to be a slightly better implementation of this, as you'll see here in a second. But that is the way we're storing. There's actually we're going to look at an even better way next class. But the way we're storing them right now is we have two separate lists. We have one list for the X's and one list for the Y's. But the cool thing about lists, and so I'm going to do a save as on this. We're going to make a slightly better version of this. So I'm going to call this stars 2. And one of the ways that this could be made better is rather than two lists, a star list for X values and one for Y values, since lists can be lists of anything, including other lists or tuples, I could put these stars in here as pairs that have an X and a Y rather than as two separate lists. So what I'm going to do is I'm going to just make one list and call it star list. I'm going to get rid of this one. Now what am I going to put into that star list? It's going to be itself a list, and that list is going to have the first element range 0 to 799, the second one range 0 to 599. So now I'm sticking in a list inside of each of those elements that itself has two elements, an X and a Y. So now I only have one list to worry about. So now when I go through this, I say, hey, go through however many things are in my list. And now rather than using an I to go through this like this, I could go through those as if they were a pair. So here I could say if, let's call this point. Let's do it the way we did it before first, and then we'll change that as well. So the length of the star list, draw a circle. Now this is going to be star list I, but that star list I has two parts to it. So now we need to do 0, that's going to give me the X. Star list I 1 is going to give me the Y. Now we're going to do this in a way that I think will be a little bit more clear here in a second, but let's run that. Notice we get the same behavior, but now we only have one list to worry about. So that list has all the pairs inside of there. A little bit cleaner implementation. Now, let me change how this works. So remember that the for loop will go through one at a time through a list. So rather than having to generate a range, we could say, just say something like this. I could say for the point, each point in my star list, and then in here, I could say, well, each point, so the X is equal to the first thing in my point, the Y is equal to the next thing in my point, and then over here, I can just say X and Y. So now we have something, look how clean this is now to get 1,000 stars on the screen. We basically have just a few lines of code, and we actually could have made this a little bit shorter. We could have done x comma y equal point. Could have done that. I'll keep it this way since it shows indexing into that point, and that point being pulled out one at a time out of that list. And there we go. There's our star field with 1,000 points. 1,000 points of light. Beautiful. All right. And now notice how easy it is to change the number. We want a different number of stars. We could change that. And one of the things that I like to do in my code is, rather than hard coding that, if it's something that's kind of a setting for the game that's going to be used throughout, then I like to use all caps like that and say num stars equal 1,000. And now when I run this, I could rebuild it and change that number. And I was like, you know what? That's too many stars. I don't want 1,000. I want 500. It looks too busy. Let's do just 500. Change in that one place, get a different number. Maybe it still looks like too many. Let me do, let's do 250. Looks better. Now we're ready to add the ship and the thruster on top of that. And maybe I want to have those stars have a wider size variation associated with them. So I could come in here in this one place in the code here. Let's go 1 to 5. Now they look a little bit crazier, but notice how easy it is to now change the code for all of them. Maybe 1 to 2. Let's see what that looks like. Much more subtle. I don't even know if you can see that, but they're flashing just a little bit. I think I liked it the other way better with 3. And if we wanted, we could add some randomness to these colors, or make the stars a little bit different. So let's say that they're more blue than the other two. So 200, 200. So now they're going to have like a bluish tinge to them, which actually looks kind of pretty. I don't know if you can see that on your on the YouTube video, but all right. Notice how easy that was to do with those lists. Now, what we're going to look at next lecture, as I mentioned, was a way to do what's called object-oriented programming, where we're going to be able to create a star object and give each star object its own x and y coordinate. And then we can reference it by star.x, star.y to access those things. And then we can also add capabilities to the star object and say star.draw or star.render. And then we could even have, we could even make objects that have their own direction and their own speed, and have a star.move and a star.draw or whatever, and have the star field kind of whooshing out away like we're flying through that on the screen. So, but for right now, let's go and stop there. That shows the use of lists in 2 different ways. One where we had the x in one list and y in another list, and then where we combine them as a pair and put them into a list, and then how to go through it as the pairs and pull out each of the components of the pair and then render with those. And really, we could have made this shorter by just saying point sub 0 there, point sub 1 there. But you'll notice how little code this actually is to now create this thing that has, I don't know, as many stars as we want. Let's say we want 2,500 stars. It's going to look pretty crowded, but looks kind of cool. I liked the bluest tinge too. And we could actually give the stars their own individual colors. And we're going to look at doing some stuff like that in the next lecture. All right, so let's go ahead and stop there. Let me switch back to the slides. So next class, object-oriented programming. We're going to get started with that. I'm going to write some code that does that. And then we're going to be ready for our kind of final required lab. One thing that I do want to mention is your final exam, since you guys have to leave the campus for home on the 24th, I think is your last day. So we're going to have our final exam on paper on the 23rd, which means that I'm going to post the final exam study guide next week, 1 week from today on the 18th. And you guys can work through that. So we're going to have that object-oriented lecture. I'm going to assign a lab with that goes with that for you guys to work on. And everything up through that is what's going to be on the paper part of the final exam. And then there's going to be after Thanksgiving break, there's going to be a kind of a bonus lab that I'm going to give you guys the option of doing. So if you've missed points on the midterm, you can make those up. And then when it comes final exam time, there's going to be like a little final exam, the kind of a programming take-home lab programming portion, which will be similar to one of the labs that we have done before. But you'll have a little more time to work on that than just the 2 hours that you have in class. And I know that some of you ran out of time when you're working on that, but we'll get all of that done. All right, so that's it for today. Everybody stay safe, and I will see you guys in the next lecture where we talk about object-oriented programming. And again, the stuff that we're covering in here is really powerful and really useful to do some really cool stuff, not just for the stuff we're doing in this class, but what you're going to do in 1802, 1803, what you're going to do in Graphics 1, Graphics 2, Real-Time Interactive Programming 1 and 2, Senior Project. All the things that follow this, you're just going to get more and more powerful until you can create a game that does anything that you can imagine. And so, but if you get off the rails and you don't learn this stuff, you're not going to be able to understand what we're doing. Not only will your grades suffer, but your capabilities, and that's really what this is about. The reason you are in this degree program or a degree program is to learn how to do things that give you capabilities to get a good job doing the kind of thing that you want to be doing. All right, let's stop there. Watch the lectures. If you missed a few, they're all on video. Go back and rewatch them. You forgot stuff, go back and rewatch them. It's good stuff, I promise. That's it. Bye.